Okay, so this is the second factoring method, factoring by grouping. So we're actually going to start about halfway through a factoring by grouping problem, which I have here as our starting example. As we saw this in class, one of a student's first instincts on something like this is to go ahead and distribute across the parentheses, which is, in this particular question, going to get us in a lot of trouble, because if we do that, we're going to end up at x cubed minus 5x squared plus 3x minus 15. And we'll still be able to work with this, but we don't have any quick ways to deal with something that has an x to the third. And there's no GCF, nothing in common we can pull out of all four of these terms. So it's actually in our best interest if we don't do that, and instead we recognize that the second factor and the two things that are being added together here are these matching binomial terms. And you can imagine here, if this were x squared times my favorite thing, cat face, right? And plus 3 times cat face. Cat face is just a stand-in for something that looks a little uglier. That these both have a factor of cat face, right? So we could go ahead, factor cat face out, and be left with x squared plus 3. And this would be a factored form because we have two things multiplied together. And if we distributed it, we would get right back out what we had started with. So the same thing is true here. We are able to factor out that x minus 3, or x minus 5, and then see what's left over. From the first, we have x squared, and from the second set, we have a 3. And if we were to take this thing and distribute it back out, we would end up exactly where we started. So this is the second actual step in factoring by grouping, and it's one that students forget a lot. A lot of students will stop here thinking that this is factored, but it is not because of that plus sign in the middle. So we actually need to get somewhere like here, where we have two things being multiplied together, two polynomials multiplied together, as opposed to something being added. So let's look at another example. It's really starting from the top. So in the factoring by grouping questions, we're going to end up with four terms. That's how you can recognize something that might be able to be solved using factoring by grouping. So we have 4 terms. There's nothing in common that we can pull out of everything. No GCF. So we need to try something new, and that's where factoring by grouping comes in. If we imagine the first 2 terms as being together in one group and the last 2 terms as being together in a separate group, we can factor them separately. So from the first 2 terms, we can pull out an x squared, which would leave us with a x plus 3. From the second 2 terms, we can pull out a 4, leaving us with an x, I want to do that in black, leaving us with an x plus 3. These are still being added together, right? So you can see here, we have x plus 3 in both of them. We're basically at that almost identical to that question we started with, right? Having the x plus minus 5 and the x minus 5. So we have one final step, which is to factor out the x plus 3 from both of them, and then bring down that leftover, or factor of x squared, and the factor of 4 from the other pieces. And you can, this is what's going to happen every single time in these factoring by grouping questions. And if we wanted to check that this actually worked, we could off to the side do a quick little distribution. If we wanted to, we could even do that inside of that box that lets us see the area method. So x cubed, 4x, 3x squared, 12, which is all the terms of our original. This is another way you could have actually solved this, is taking these 4 terms and putting them into the box and then taking a GCF out of each row and column to figure out which original factors were. So that's it. That's factoring by grouping. I'm going to go ahead and give you guys 2 more just to try on your own. So pause the video and see if you could do this one after I write it down. So let's do 4t to the third minus 15 plus 20t squared minus 3t. All right, so pause the video, try it out. Okay, so this particular problem ends up giving you some trouble, right? If you try to factor this by just doing the first two and last two terms the way we did in the first one, you get into trouble because there's nothing in common that you can even pull out in the first two terms. So something you might have noticed as you were working on this, though, is that this particular polynomial is not in descending order. We're used to seeing these where the degree of each term is decreasing, right? So we might want to put this in descending order and see if that helps us. So if you didn't recognize that originally, we could rewrite this in descending order. So degree 3, degree 2, degree 1, degree 0, and then try again. So if you couldn't get this far before, pause again, see if you can do the grouping now. Now it should work if you have your two groups. For the first group, we're going to pull out a 4t squared, which will leave us with t plus 5. And in the second group, we're going to pull out a negative 3, which will leave us with a t plus 5. One thing to notice here is sort of a pattern, is that whatever sign is between the two terms, you will pull out that version. So if it was a plus 3t, you need to be pulling out a positive 3. Since it's a minus 3t, we're going to pull out a negative because this was positive and we need this to end up positive as well on the inside. So again, our little binomial terms match. So our final answer is 4t squared minus 3 all times t plus 5. And one more, just in case you want to feel really good about yourself. Let's do t to the 5th minus 5t to the 4th plus 10 minus 2t. All right, this one also has a little tricky piece to it, so good luck. So again, this thing is not in descending order. If you spot this right at the beginning, you're going to get yourself from making the mistake that would make this a little bit tougher. So I am immediately going to rewrite this so that it's in descending order, minus 2t plus 10. Now we're not going to get in the trouble that you might have gotten in with this problem. So from the first two, we can pull out t to the 4th. And from the last two, a negative 2. And then we're done. Those two are slightly tricky because of the not being in descending order, but that's sort of the trick to factoring by grouping. If it doesn't work, put it in descending order and it will. There are some that don't work. Just to give us an example of that when it fails, something like this, x cubed minus x squared minus 2x plus 5. It's in descending order. So if it's going to factor by grouping, it should work. But if we do this, we can pull out an x squared from the first two, leaving us with an x minus 1. But there's no way I can make that back half look like x minus 1. There's nothing in common between 2x plus 5, so this would be non-factorable. So just because it has 4 terms does not mean it has to factor by grouping, but it's a good place to start if it has 4 terms. So that's it.